Ma'am, visible?
Yeah, it's visible, ma'am.
So good morning everyone. Today I and Amit are going to present on concurrency control in database. So we will discuss four topics in our presentation, that is log based protocol, timestamp based protocol, validation based protocol and multi-version schemes. So what is concurrency control protocol? A concurrency control protocol is a set of rules enforced by the DBMS to ensure serializable schedules, also known as CCMs, that is concurrency control method. So main protocol of concurrency control protocol is 2PL, that is two phase locking, which is based on a locking on which is based on locking the data items. So log based protocol. What is lock? Lock is a variable associated with a data item that describes the status of the item. The simplest kind of lock is a binary lock which secures permission to read or write a data item for a transition. So a binary lock can have two state that is locked and unlocked, which we call as 1 or 0 for simplicity. So a distinct lock is associated with each data item X. So in here, if the value of the lock on X is 1, item cannot be accessed by the database operation that requests the item. If the value of the lock on X is 0, the item can be accessed when requested and the lock value is changed to 1. So here we have taken two operations, lock item and unlock item are used with binary locking. A transaction requests access to the item X by issuing a lock item X operation. If here lock X is equals to 1, the transaction is forced to wait, and if lock X is equals to 0 is set to 1 and a transaction is allowed to access item X. When a transaction is through using the item, it issues an unlock item operation back to 0 so that the X can be accessed by the other transaction. X can be accessed by the other transaction. So here a binary lock enforces a mutual exclusion on the data items. So we have two essential components on two-phase locking techniques, that is lock manager and lock table. So lock manager is like a subsystem of DBMS that manage a lock on data items, and whereas lock table uses to store information about the log data items such as data item ID, transaction ID, lock mode, list of waiting transaction ID, etc. So here lock manager can be implemented as a separate process to which transactions send lock and unlock requests. So lock manager replies to a lock request by sending a lock grant message or a message asking the transaction to roll back in case of a deadlock. So request transaction waits until its request is answered, and the lock manager maintains data structure called lock table to record granted locks and pending requests. The lock table is usually implemented as in a memory hash table index on name of the data item being locked. So there are some rules for locking. A transaction T must issue the first rule is a transaction T must issue the operation lock item X before any read item or write up item operation are performed in T. And second rule, a transaction T must issue the operation unlock item after all read item and write item operation are completed in T. The third rule is a transaction T will not issue a lock item operation if it already holds the lock on item X. And the fourth rule, a transaction T will not issue an unlock item operation unless it already holds a lock on item X. So these were the four rules for locking. So we'll move on to the shared and exclusive mode. Um, we have shared and exclusive mode, also called read write mode. Read write mode. So in here, a read log mode is in an exclusive mode. Item can both be read as well as written, and in a shared mode, item can only be read. Um, a read log item also called shared log because other transactions are allowed to read them, whereas a write log item in exclusive but because a single transaction exclusively holds the log on the item. So lock requests are made to the concurrency control manager by the programmer, and a transaction can proceed only after a request is granted. Lock conversion. Um, so lock conversion, it is desirable to relax like in a lock conversion is what that transaction has already a lock on item X is allowed under certain condition to convert the lock from one lock state to another. For example, it is possible to upgrade for transaction T to issue a read lock and then later to upgrade the lock by issuing a write lock operation. If T is the only transaction holding a read log on X at a time it issues a write log operation, the log can be upgraded. Otherwise, Otherwise, the transaction must wait. It is possible for transaction T to issue a write lock and then later to downgrade the lock by issuing a read lock operation. When upgrading and downgrading of lock is used, a lock table must include transaction identifiers to record structure for each lock to store the information on which transaction holds lock on the item. So we have two type of lock conversion, like lock upgrade and lock downgrade. Lock upgrade, what it does, it upgrades the log read lock to a write lock, and whereas lock downgrade, it downgrades the write lock to read lock. So we have two phases for two-phase locking rule. Uh, if all the locking operation precedes the first interlock operation in a transaction, such a transaction can be divided in two phases: the expanding or growing phase, which during which new locks on item can be acquired but none can be released, and second is a shrinking phase during which existing locks can be released but no new locks can be acquired. If the lock conversion is allowed, then upgrading of locks must be done during the expanding phase and downgrading of lock must be done in the shrinking phase. So protocol assures serializability if it can prove that the transaction can be serialized in the order of their lock points. So we have many variations of two-phase locking. We have like conservative 2PL, strict 2PL, and rigorous 2PL. So there are a number of variations. A variation known as conservative 2PL requires a transaction to lock all the item it accesses before the transaction begins execution by pre-declaring its read set and write set. Um, in practice, the most popular variation of strict 2 is of 2PL is a strict 2PL, which guarantees strict schedules. In this variation, a transaction T does not release any of its exclusive lock until after its commit or aborts. Hence, no other transaction can read or write an item that is written by T unless T has committed, leading to a strict schedule for recoverability. Strict TPL is not deadlock free. A more restrictive variation of the strict 2PL is a rigorous 2PL, which also guarantees strict schedules. In this variation, a transaction T does not release any of its log until after it commits or aborts, and so it is easier to implement than strict 2PL. So deadlock. So what do you mean by deadlock? A deadlock occurs when each transaction T in a set of two or more transactions is waiting for some item that is logged by some other transaction T dash in the set. Hence, each transaction in a set in a waiting queue waiting for one the other transaction is waiting for one of the other transaction in the set to release a lock of an item. But because the other transaction is also waiting, it will never release a lock. So in this condition is called a deadlock. Um, in the below example, you can see where two transactions T1 dash and T2 dash are deadlocked in a partial schedule. T1 dash is in the waiting queue for X, which is logged by T2 dash, where T2 dash is in the waiting queue for Y, which is logged by T1 dash. Meanwhile, neither T1 dash nor T2 dash nor any other transaction can access item X and Y. So deadlock prevention protocol. Um, so we have two types of schemes for deadlock prevention protocol, that is wait die scheme and wound wait scheme. So there are difference between wait die scheme and wound wait scheme. Wait die scheme is non-primitive, and whereas wound wait scheme is primitive. Wait die scheme is older transaction and may wait for younger one to release data items. Younger transaction never wait for older ones; they are rolled back instead. Whereas the wound wait is an older transaction wound of younger transaction instead of waiting for it. So younger transaction may wait for older ones, and wait die is a transaction made in a wait die transaction it may die several times before acquiring the needed data items, whereas wound wait may have a few rollbacks and wait die scheme than wait die schemes. So both in wait die and wound wait scheme, a rollback transaction is restarted with its original timestamp. Older transaction does have precedence over newer ones, and starvation is hence avoided. So in a time-based scheme, we have a time-based scheme also. A transaction waits for lock only for a specified amount of time. If the lock has not been granted within that time, the transaction is rolled back and restarted. Thus, deadlocks are not possible. Simple to implement, but starvation is possible. Also difficult to determine good value of the timeout interval. So there are several other protocols for the deadlock, like we have conservative 2PL, a no waiting protocol, and a cautious waiting. We have already known about the conservative 2PL. So in the no waiting protocol, no waiting, if a transaction is unable to obtain a lock, it is immediately aborted and then restarted after a certain time delay without checking whether a deadlock will actually occur or not. In this case, no transaction ever waits, so no deadlock will occur. However, this scheme can cause transaction to abort and restart needlessly. In a caution waiting protocol, algorithm was used to try to reduce the number of needless aborts restarts. Like for example, if TJ is not blocked, not waiting for some other log item, then TI is blocked and allowed to wait. Otherwise, TI is aborted. We can detect that we can detect the deadlock. So in this approach, deadlocks is allowed to happen. The system maintains a wait for graph for detecting cycles. If a cycle exists, then one transaction involved in a cycle is selected and the other is rolled back. So a wait for graph contains a node for each transaction. When a transaction say Ti is blocked because it requests an item X held by another transaction Tj in conflicting mode, a directed edge is created from Ti to Tj. The system checks for cycle. If a cycle exists, a state of deadlock is detected. So we have timeout and starvation deadlock detection. A timeout is another simple scheme to deal with a deadlock is to use a timeout. This method is practical because of its low overhead and simplicity. In this method, if a transaction waits for a period longer than the system defined timeout period, the system assumes that a transaction may be deadlocked and aborts it, regardless of whether deadlock actually exists. In starvation, another problem that may occur is we use locking is starvation, which occurs when a transaction cannot proceed for an indefinite period of time, while other transactions in the system continue normally. This may occur if the waiting scheme for log item is unfair in that is it gives priority to some other transaction over there. And now we'll move on to the timestamp based protocol. So what is timestamp? Timestamp is monotonically increasing identifier, an integer or system clock time when a transaction starts, indicating the start order of a transaction. So a larger timestamp value indicates a more recently started transaction. So, in order to assure such behavior, the protocol maintains over each data queue two timestamp value, that is W timestamp and R timestamp. W timestamp is a larger timestamp of any transaction that executed write successfully, and whereas a R timestamp is the largest timestamp for any transaction that is executed read successfully. So timestamp ordering is protocol ensure that any conflicting read-write operation are executed in timestamp order. So now Amit Kannam will continue after this. Amit?
Am I audible?
Yes, you can continue.
On to validation-based protocols. So as the name suggests, validation-based protocol is used to validate data before it is written into the database. So it happens in three phases: the read and execution phase, the validation phase, and then the write phase. So the read and execution phase is where the transaction writes the data. It doesn't write the data into the database directly, but it is written into a temporary variable. And in the validation phase, validation occurs to see if the local variable is not violating any serializability. So if this validation passes, in the write phase, the data is written into the database, otherwise it is rolled back. So since we rely or hope that the data is validated, this this protocol is also known as optimistic concurrency control. So moving on to the next slide, we see that the timestamp has, the validation based protocol. 1 minute, ma'am. Akansha, can you move on to the next slide? Yeah, so we see here that each transaction has three timestamps. That is timestamp when it starts, and then the next one when validation occurs, and then when it finishes. So start timestamp usually indicates the time at which the transaction has started, and then validation timestamp usually is the time at which validation occurs, and finish timestamp is when the data is written into the database, right? So moving on, we take an example here, right? So validation test for transaction Tj. So let us consider two transactions, that is T of I and T of J. So there are two cases here. So if the transaction J, if the timestamp of transaction J is greater than timestamp of a transaction I, it means two things. Either the transaction J starts after the finishing of transaction I, or the transaction